Okay, here we go. Okay, I really don't think we need to do all of those problems because they're all the same. You do the same thing. You take the first derivative, you make a number line. You take the second derivative, you make a number line, and done, it's done. Okay, number 13. Okay. People, if you have a polynomial function, it can't be easier. Okay, first step, take the derivative. 12x squared plus 42x plus 36. Okay, make a number line for this. So we need to factor. What can I factor out? 6. 2x squared plus 7x plus 6. Is that factorable? Yes, because that's why I assigned it. 2x and x, 2 and 3 plus and plus. So number line, see how I label my number line? And some of you guys just negative 2, negative 3 halves. How do I know it's plus minus plus? Because if I graph this, it's a parabola opening up. It's above, below, above, or just plug in number. So y is increasing. Y is decreasing. Y is increasing. So there's a maximum here, right? Because if it goes up and then down, there's a max, and of course this is going to be a low. How do I know it's local? Because a cubic function looks like this, right? The thing goes up and down forever. This is not the highest point on the whole graph. It's going to be local. There's a local max at negative 2 comma something, and right here is going to be a local min at negative 3 halves comma something. How do I figure out these somethings? You plug it back into the original. I'm going to save time. You guys do that. Or how about just look at the answer in the back? That's low. Now we got to look at the second derivative. So first step, find the second derivative. Now all three of these are the first derivative. Which one is the easiest to take the second derivative? The first one, because it's all multiplied out. So you get 24x plus 42. I can factor out. What?
Why double prime?
There is the double prime there. Factor out of 6 and you get 4x plus 7. So when you make your number line, the only thing going to have on there is negative 7/4, and then it's going to be minus and plus. How do I know that? Because if I graph that line, uphill positive slope, it's going to be below and then above, right? Or just plug in numbers. What do I need to write under here on full credit? Y is concave down. Y is concave up. So is negative 7/4 a point of inflection? Yes, because it changes concavity. A point of inflection is where the graph changes concavity. So there's a point of inflection at negative 7/4 comma something. And how do I find that something? You plug it back into the original. I will let you do that. Or just look at the answer in the back. Okay, I'll tell you what. Number 1 on tomorrow's quiz. This is it right here. I'm going to give you a polynomial. And I'm going to actually draw the graph. I drew the graph on my graphing calculator and everything. Put the picture in there. So the graph is there. And all you got to do is tell me where are there maximums, minimums, and points of inflection. But you got to have all this now. I'm looking again. So if you don't label your number line twice tomorrow, it's minus 2. If you don't have this increasing, decreasing stuff and concave down, it's minus 1 for each one missing. And don't worry, I won't make it come out to fractions like that. I'm not going to come out to whole. Well, of course, that's assuming you do the problem correctly. If you make a mistake, you're going to have fractions and stuff. Okay, next, 28. Good choice. Do you remember doing this problem on 4.28? Didn't we do this exact same problem in 28? Does anybody remember it? In section 4.2? No, 4.1? Okay, never mind. I wouldn't be surprised if I just give you this on the test. The same problem. Yes, I remember now, because I drew the graph for you on the board, remember? Remember I told you the graph looked like this? It was right here. I remember it now. Now it's all clear to me. I drew the graph right there. If I didn't draw it in the same place, maybe then you guys would get a deja vu. Remember the graph looks like this?
Oh yeah.
Remember I told you since the degree of the bottom is bigger than the top, then y equals 0 is the horizontal. So we did do this problem. So this point is an absolute max, this point is an absolute min. The only difference is now we gotta also find the points of inflection. Okay, so here we go. First derivative. Looks like quotient rule, people. Low, d high, minus high, d low. All over the denominator squared we go. Simplify the top. Now does it start to look familiar? It still doesn't look familiar, Mr. Parker. Get out of here! You want to factor this as 1 minus x times 1 plus x, or you want to just leave it? Because you just know the roots are plus or minus 1. Okay, let's factor it. I'm waiting for a response. She's not responding, Captain. Label the number line. Okay, what makes the top 0? Negative 1 and 1. Nothing makes, remember? Nothing makes the denominator 0. Remember, it's always positive. Does that sound familiar? Okay, think of a number bigger than 1, like 2. In fact, we did this already. Positive times negative, then divided by positive, because the denominator is always positive. So it's going to be minus plus minus, which means y is decreasing. Y is increasing. Y is decreasing. So, you can see from this number line, there's a minimum here and a maximum there. So this is the absolute minimum at negative 1 comma something, and this is the absolute maximum at 1 comma something. How do I know if these are absolutes? Because the graph looks like that. You have to know something about the graph. Who's twinkling? Oh, man. You guys can eat, but no crinkling. Okay, how do I find the y coordinates? You plug it into there. Okay, now let's move on. Second derivative to find the points of inflection. Now, all three of these are the first derivative. Which one should I look at to find second derivative? A, B, or C? B. That's the easiest one. So low, d high, minus high, d low. I see box squared. How do I take the derivative of box squared? 2 box to the first times the derivative of box. All over denominator squared we go. Okay, you know what the hard part is in this problem? Factor that so I can make a number line. How do I factor this, Mr. Park? Well, I can factor out an x squared plus 1, and I can also factor out a 2x. Shall we factor out a negative 2x? Yes! And then what's going to be left? X squared plus 1 plus 2, 1 minus x squared, there. All over denominator squared we go. Hey, but doesn't this cancel with one of those? Yes. Simplify what's in the brackets. So you get x squared plus 1 plus 2 minus 2x squared. So that comes out to negative 2x times 3 minus x squared all over x squared plus 1 cubed. Okay, that's where you got to get. And this is where everybody's copying. Okay, got it. Now we are ready for the number line. What do I put on my number line? What makes the top? The bottom is always positive again, right? What makes the top positive? I mean 0. 0 and plus or minus √3. Okay, what kind of signs do I put on here? Maybe if you did it this way, okay, you see this negative sign, if you distribute it in, maybe it would be, is it easier for you to look at it like this? Yes, because look, how do you, okay, let's say we don't know anything then. Think of a number bigger than radical 3. 2. Positive, positive, positive. Think of a number in between here, like 1. Positive, negative, positive. Think of a number here, think of a number there. I'm just going to do it. You guys gotta practice doing that, Y is, oh, wrong way. Y is concave down. Y is concave up. Y is concave down. Y is concave up. So where do I have points of inflection? At all three of these points, does it change concavity? Yeah, because the signs change, right? So you have a point of inflection there, there, and there. How do I figure out the y coordinates? Plug it back into the original. I'm going to let you do that. Or just look at the answers in the back, but there is none because it's even. Ha! Take that. And doesn't that make sense? Because look, you have point of inflection here, here, and here. Because look, it's concave down. Now it changes to concave up, right? And then at 0, then it changes to concave down. And then right here, now it changes to concave up. It all makes sense. Okay, that was probably the hardest problem on the homework, I would say. I don't think I assigned anything more difficult than that. Okay, 29. Yeah! There we go. Okay, 29. They're asking, where do you have maxes, mins, points of inflection? Now, in this problem, they gave you the first derivative already, and it's all factored. So all you gotta do, make a number line already. Y prime, 1 and 2. How do I know it's gonna be plus, minus, minus? Because there's an even power on this one, so you're gonna have same signs here and here around the 1, right? Or just plug in numbers. So here, just real fast. Y is decreasing, Y is decreasing, Y is increasing. I have a legend, okay? So, what's at 1? Is this a max or a min? Or neither? If a graph goes downhill, and then it goes downhill some more, is there a max or a min there? No, there's nothing. There's nothing at x equal 1. What about at x equal 2? If the graph goes down, and then it goes back up, that's a minimum. So there's a relative min at x equal 2. Okay, now how do you find points of inflection? You gotta find second derivative. Okay, now how do you want to find the second derivative? Multiply it out, or you want to use product rule? I think product rule would be simpler. So derivative of the first, 2 box to the first times the derivative of the second one alone, plus leave the first one alone times the derivative of the second, which is 1. And then we need to factor. I can factor out x minus 1. What's left? 2 times x minus 2 plus x minus 1. So that comes up to x minus 1, and 2x minus 4 plus x minus 1, that's 3x minus 5. So when you make your number line, woo, you got 1 and 5/3. It's going to be plus minus plus. Y is concave up, Y is concave down, Y is concave up. So how many points of inflection are there? 2, because it changes concavity from up to down, right? So at x equal 1 and x equal 5/3, you have points of inflection. So, the lesson to be learned here, to answer any of these questions, all you gotta do is take the first derivative, make a number line. Take the second derivative, make a number line. That's what you're doing on tomorrow's quiz, basically. Just pray you don't get this one right here. No, you're not gonna get this one. I'll just tell you. It's gonna be a polynomial, number 1. So, hopefully you can do that. And I'm gonna give you the graph on top of it. Okay, 29, 33, and 43. 33. Okay, 33. Just basically, you know the information they give you there, just make a number line from it. And 41. Where's 41? Okay, let's do 41. Okay, so, 1, oh gosh, do I really have to draw this? Okay, here's 6. Okay, when does it reach its maximum? It looks like 2, yeah? So it goes like a 2, and then 6. And then it peaks out at 10, and then at 15, it starts to flatten out like that. Okay. So this is the graph of the distance. So position versus time. That's basically what this is. Okay, let's answer the questions. When is the velocity equal to 0? Well, if this is the graph of position, what is velocity? Velocity is the derivative, right? And the derivative tells you the slope. So basically they're asking you, where is the slope 0? Here, 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 and there, right? So the answer would be 2, 6, 10, and 15. That's when the velocity is 0, because that's where the slope is 0. Okay, part B. When is the acceleration equal to 0? Now, what is the acceleration? The second derivative. How do you tell when the acceleration is 0? When the second derivative is 0, then what does the second derivative tell you?
It's neither concave out nor
Yeah, where it changes concavity. So look, just look at the graph. Over here it's concave down. Where does it change to concave down? Right about there. Then now, so it's concave down rather. And then now it changes to concave up. Well, I'm not sure on my graph, I might have drawn it different from the one in the book. Now it's concave up. Where does it change to concave down? Somewhere over there. Now it's concave down. And then right about here, it changes to concave up. These are your 3 points of inflection. That's when the second derivative will be 0. And where would that be? So if I look at the thing, I would say around 4. Now you cannot be exact, so if you said 3.8, I would have to give that to you. And then where else does it change concavity? Around 8.37. Okay, and then where does it change concavity again? Actually, it's more over here. Yeah? If you look at the one in the board, it's going to be around 13. Yeah.
For A, it doesn't really reach 15, so.
Oh yeah. It doesn't really reach 50. Yeah, I mean the graph stops there, but you can kind of see it flattening out, right? So the slope would be 0 there. Yeah.
Okay, so.
Yeah, you count that. Yeah, that's all you have to do is just look at the graph, look at the slopes and the concavity. That's what the second derivative is all about. It's about the concavity. Okay, we're moving on to 4.5. Okay, so if these, number 33, try and make a number line from it. If you make a number line from it, that answers all the questions, that's why. Whenever you're stuck on the AP exam, whenever you're stuck, go to the bathroom first and then make a number line. No, I'm telling you, you make a number line. Everything is apparent already. Okay, 4.5. I thought you guys had trouble. Only got 2 questions. There were 4 total questions. Okay, let me prioritize for you. Number 2 and number 15. I didn't, 12. Sorry, I didn't decide to. Wait a minute. Wasn't my example yesterday the square root of x? And then the book has cube root of x, so all hell breaks loose.
Yeah.
Okay, here we go. Let's do number 12 first because this kind of looks like very familiar, like for tomorrow's quiz. Cube root of x, which is x to the 1/3. Okay. So they want you to write the linearization at a value that's close to 8.5. So what would be a good number to use in this problem? 8 or 9? Yeah, why do you want to use 8? Yeah, because the cube root of 8 is 2, which is a nice number. But don't worry, tomorrow I'm going to tell you. I'm going to say, write the linearization of this at x equal 8. So you don't even have to guess. You know what I mean? Okay, so when x is 8, how do you figure out the y coordinate? You plug it in and you get 2. Now to write the equation of the tangent line, you have to compute the slope. How do I compute the slope? You take the derivative. So the derivative of this is 1/3 x to the negative 2/3. So if I plug in 8, remember, it's not the slope until you actually plug in the number now. So if I plug in 8 here, you get 1/3 times 1 over 8 to the 2/3, which is 1/12, correct? How do you write the equation of a line with that slope and that point? Y minus 2 equal 1/12 times x minus 8. Now you want to leave the 2 here or you want to put it on that side like I showed you yesterday? Okay, don't answer me. Let's just move the 2 on that side. Okay, now what we're doing in this problem, what are we doing in this problem? Oh, okay. Basically what we're trying to do is we're trying to estimate the cube root of 8.5. The cube root of 8.5 is not that easy to compute without a calculator, so we estimate it with the tangent line. So instead of plugging 8.5 into this, we plug in 8.5 into this. So what is y of 8.5? What is 8.5 minus 8.5, which is 1/2, right? What is 1/2 times 112? 124, so 2 and 124. This is a good estimate of the cube root of 8.5, which is pretty close. Remember how yesterday we did it on the calculator? It was pretty darn close. You don't have to do that anymore, just assume it's close, because we're A and B, right? And that's all we have to do. Okay, but tomorrow's quiz, in addition, I'm going to ask you, is this an overestimate or an underestimate? And you got to explain why. Okay, were you guys here yesterday? How do you determine if it's an under or an what did it say? Over or an underestimate? You need to know the concavity at the graph at this point. If the graph is concave down, then when you draw the tangent line, then isn't the point on the line above the point on the curve? So it's an overestimate. But if the graph is concave up, when you draw the tangent line, the point on the line will be below the point on the curve, so you're going to have an underestimate. So we have to determine the concavity of the graph when x equals 8. How do I do that? You got to find the second derivative. So I find the second derivative of this, which is going to be -2/9, x to the -5/3. When x is equal to 8, so what you have to do is you have to plug in 8. What is 8 to the -5/3? 1 over 32. But 2 cancels into that 16 times, so you get -1 over 144. Is that a positive or a negative number? Oh, so I see a negative sign there. It's a negative number, which means the graph is, so f is concave down, therefore the tangent line is above, so the point on the line is above the actual point on the curve. So this is an overestimate. So this number here is an overestimate. Why? Because f double prime of 8 is equal to -1 over 144 is negative, which implies that f is concave down. Or you could say f is concave down since f double prime of 8 is equal to -1 over 144, which is negative. Yeah.
So what you said is negative to that fraction?
No, they want to see the actual number. So if you compute this number wrong, that's an automatic -1. So let's say you compute this number wrong, and what if it came out positive? Let's say you came out with this. Then your conclusion has to be, this would be an underestimate, right? Because f is concave up. Therefore, the point on the line could be below the point on the curve. That's why they want you to compute this number. They want to see the number. I want to see the number tomorrow. Does that clear it up? Okay, and then what's the last one? Number 2. Okay, it's the same thing. Maybe, are you guys not understanding the problem? Is it confusing the directions? Okay, don't answer. Number 2. No, we're just putting it on the board because they're even. f of x is equal to square root of x squared plus 9. So, at this point, they want you to write the equation of the tangent line, and then they want you to estimate at -4 plus 0.1. So at -3.9, see, instead of plugging -3.9 here, you're going to plug in -3.9 into the line equation. Okay, so when x is -4, how do I find the y coordinate? You plug it in, you get, I'm trying to open my hand, you cannot. 5. How do I figure out the slope? You gotta take the derivative. Okay, how do you take the derivative? Just like box to the 1/2. 1/2 box to the -1/2 times the derivative of box. The 1/2 cancels the 2. So what happens when I plug in 5? No, we're not plugging in 5. What happens when I plug in -4? 25 to the -1/2 times -4. So this is -4/5. Did I do that correctly?
Yes.
Yes. So, point slope, y minus 5 equal -4/5 times x plus 4. Move this 5 on that side. Y equal -4/5 x plus 4 plus 5. Take this number, plug it into the line equation. Okay, what is negative 3.9? What is negative 3.9 plus 4? 0.1, which is 1/10. What's 1/10 times negative 4/5? There, I wrote. Now do you see why if you leave it in point slope form, it's way easier to work with? 4 goes into that, 2 and 5. So what is that? That's negative 2/25 plus 5. So isn't that 4 and 23/25? So that is an estimate of, see, if you take negative 3.9 and try to plug it in there, that's ugly. It's hard to figure out. But if you take negative 3.9 and plug it into this, it's easy to figure out. It's 4 and 23/25. So this is a good estimate of plugging in negative 3.9 into there, which is not that easy to figure out. You guys understand linearization? Oh, wait a minute. No, because it says at a plus 0.1. So you have to add 0.1 to it. So whatever number they give you, they want you to estimate it when you add 0.1 to it. Yeah, so negative 3.9. Don't worry, I'm gonna spell everything out for you, so. Okay, the bell's gonna ring. We have a worksheet. Where is it? Okay, you got 2 practice tests. 1, 2, 3, 4. Okay, pass it back. Pass it back to
Apparently just ready my neighbors too.
1, 2, 3, 4, 5.
You have to.
Yeah, because we're learning lessons.
Yeah,
Ken's not here. Okay, anyway, if you do like number 1, number 4, and number 5, that's really going to help you on tomorrow's quiz. And then number 7, you might have a hard time with because I wanted to teach you that, but we ran out of time. I'll teach you tomorrow. I'm going to take a look at it. Love?
Oh, wait, no, okay, no,
Thank you, Mark.
Oh, yeah.
Okay, I got one.
Yeah, okay. Yeah, I remember seeing that. But you see what went wrong? Once you make this mistake, then yeah. Okay, I will give you the 3 then.
Yeah, no, I told him yes.
Yes, you need calculator tomorrow.
And no, we didn't.
I don't know. Oh, no, or you at least said faculty these are down 10 per month. You finish here? What? Last signature?